Cool, good morning. All right, I'm going to start off the language track by saying I don't give a damn what language you use. I really don't. I'm not up here to sell you on any programming language. Instead, I just want to show you some stuff. And if you think it's cool, then maybe you'll use it. And if you don't, you won't. I've probably been mostly associated with Ruby over the last 15 years. I started using Ruby in '98, and I've been using it pretty much ever since. And the reason I've been using it is that, frankly, I've never come across another language which I kind of loved. All right, the Ruby I loved as a language. It's a great language. It's a friendly language for me to use. It does what I want, and it makes me feel happy. And I do so much programming every day that if I'm not feeling happy, then that's a waste of a life. So I want something that's going to make me happy. Now, the reality is that 15 years is a long time to be monogamous. I've always been flirting with other languages. I've always been looking for other languages to give me that kind of thrill, and I've never really found one. The other thing I've been looking for is a language that would help me try and show some of the concepts behind functional programming. And one that was like deep enough that I could show a whole bunch, but also not scary enough that I'm going to put people off. And I was talking about this, a year or so ago, and the idea came up to look at Elixir. Now, Elixir is a functional programming language. It runs on the Erlang virtual machine. Now, how many people have looked at Erlang? How many people keep using Erlang? Half. Okay, 2. That's 1. Between you, that's 1. Okay. And that's actually quite often the concept, right? Erlang is a really cool language. And given its age, I mean, it's like mid-80s it started out, it's really a fantastic language. It's kind of like, you know, the love child of Prolog and Haskell or something like that, right? It's a really strange mixing of some really cool concepts, and it pulls it off really well. But it's a slightly weird language. But Elixir is a bit like Scala or Clojure running on the JVM. Elixir is a more modern-looking language that runs on top of the Erlang virtual machine. So you get all of the benefits of Erlang for free. For example, we can write our code that can be distributed, it can be concurrent, it can be scaled, you can get incredibly high reliability if you follow the kind of general rules for creating the code. It's a fantastic environment for writing code. So I really like to push Erlang now. And the reason I do it is because I think it's, anybody here doubt this slide? Does anybody deny this slide? Some people do. So, I mean, the classic way of explaining this is to show people Moore's law. That's not really the right Moore. Although, wouldn't it be cool if Moore's law was that, you know? Yeah, do it my way or I'll shoot you, and make a joke at the same time. But no, Moore's law, Gordon Moore, number of gates on a wafer will, okay, double every, some people say 18 months, some people say 2 years. Moore himself changed in the middle, but it's kind of true. So this is a graph of number of gates, or actually number of transistors, on microprocessors from the year 1971 up to a couple of years ago. That graph is logarithmic, so the fact it's a straight line means that we have actually seen that doubling taking place. The first processor I worked on actually is that one there, that 4004. And that had, I don't know, what's that, 2,300 transistors on it. You could probably see them if you looked hard enough. My laptop, scarily, has 1 billion transistors on it. Unbelievable, unbelievable. Somebody actually went to the trouble of measuring the processor and came up with a transistor density of 8.26 million per square millimeter. How big is a square millimeter? Well, I finally found a use for this guy, is if you cut into a paperclip, that's a square millimeter. So 8.26 million transistors in a clippy, which is unbelievable. Nobody can keep 1 billion transistors busy by trying to get them all to do something at once. The only way you can do that is by dividing your work up. And that's what we're going to have to do. So the future is functional. and the future is concurrent. I don't think there's any argument about that. So, Elixir. I was thinking about how am I going to do this? I could sit here and give you an introduction to Elixir, but you know what? There's really great tutorials on the web, so I'm not going to do that. I am going to tell you that Elixir has all of the kind of buzzword compliant things for the kind of language we're talking about. So it has immutable data, it has pattern matching, it has hygienic macros, first-class functions, blah, 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 right? Who cares? It's just a language. But what I do want to show you instead of showing you the programming language, I want to show you something else. And I'm going to use Elixir to do it. Because I am increasingly convinced that in the old days, we were all concerned about state. Programming was about maintaining state. It was about class invariance. It was about hiding data. It was about object orientation. But now I am convinced that all programming is about transformation. When you think about it, in object orientation, we're concerned with hiding data, we're concerned with state. In functional programming, we're concerned with transforming data. Well, which one actually gets work done? It's the transformation, right? When we think about object-oriented programming, we think about hiding data and, coupling data and functionality together. So we have data and methods all in a class. With functional programming, we separate the two out. We decouple them. So which ones may lead to more flexible designs? However way you look at it, I think programming is now transformation. And clearly, we're talking about transformation of data. Right, that's kind of the basis of functional programming. Right? We have some blob of data, we feed it through a function, we get another blob of data. And that data might itself be a function, but that's just technicality. But I also think we're reaching an age where we have to think about the transformability, if that's a word, of the code as well as the data. Because as the world gets more complex, clearly we can no longer design up front. We can no longer, to me, object-oriented programmers are a little bit like those Victorian gentleman scientists who used to go around the world and try and classify butterflies, right, into these incredible hierarchies. And we have this kind of like, right now in biology, we have the class, genus, species, all this kind of stuff, right? All these hierarchies. And that's kind of the way OO is. We try and think of things in terms of all these class hierarchies. We're not doing OO programming, we're doing class-oriented programming. We're dividing our world up into these incredible static hierarchies. But that's no longer the way we're coding. We can't do that in a world that's as dynamic as our current world. So flexibility and transformability of code is critical if we are going to basically generate the next version of the web over the next 20 years. So I want to talk to you and I want to show you transformation. Okay, now I warn you, this talk, I've got 40 minutes left. I'm either going to finish in 20 minutes or I'm going to finish in 3 hours because I'm planning to live code the rest of it. God help us all. Time for a drink. That's not gin. All right, let's find my editor. Okay, so I'm not going to show you all of the features of Elixir, and I'm not going to sit there and say, hey, look, here's how you do Fibonacci with pattern matching, right? You either know that already, or it's just really easy to look it up. So instead, I want to get straight into the idea of transformation. So let's start off. Okay, I am going to do a pretty boring example. I'm going to do anagrams, all right? And just because it happens to let me show you some of the stuff I want to do. So anagrams, right? These are words that have the same letters in different orders. And given a dictionary, I can find anagrams of words by creating a signature such that each word that's an anagram has the same signature. And the obvious signature is you take the characters in the word and you sort them, and then all words that have the same characters in them will look the same sorted, all right? So you create a hash where the key is the signature, and then there's a list of all the words that have that signature. And that gets you anagrams, okay? So let's create a module, dictionary. Okay. In Elixir, all of our code, well, not all of it, 99% of it goes into modules. And the reason is that in the Erlang world, a module is a unit of code that can be replaced. You may have heard that in Erlang, I can replace my code dynamically at runtime. That's how it achieves 9 nines availability. So I can swap a module out at runtime and then choose at what point during a transaction to bring that new module live. So I write all of my code in modules. And as a result, well, I'll talk about that in a minute. So let's create some code that does a signature. So I'm going to create a method called signature. And it takes a word. Oh. Okay. Now, how are we going to do this? Let's do this the obvious way. So I'm going to say something like character. I'll do chars. I can't type. Equals string to list on the word. And then I'm going to say sorted equals enum dot sort chars, and then I'm going to reassemble them back into a string. I don't technically have to do this, but I may as well. So I'd say toString on sorted. Yeah? So far, so good. First of all, Ruby programmers, yeah, look familiar? Yeah, if you kind of squint and ignore those little do's that hang off the end there, then yeah, that could be Ruby code, right? Pretty cool. Is this good Ruby code or Elixir code? Well, to me, not really, because I have all these intermediate variables which kind of get in the way of my reading of what I'm writing, and they also give way too much prominence to the intermediate products of what I'm doing. So what can I do about that? Well, one thing I can do about that is to take my code and do this instead. I bet you could do this in an IDE. I bet you could do substitutions like this. Look at that. How about that? Well, I got rid of my intermediate variables, right? Now, imagine you wrote this code, and then you went away from it for a year, and then you came back and you had to read what you just written here. So you look at this. How do you actually parse this? Well, the only way to parse this, really, is you've got to start at the beginning and look for opening parentheses, and then when you get to the last one, then you've basically got something, and then you've got to scan backwards to work out what you're actually doing with it. So you've got this kind of like shuttling back and forth, inside-out parsing of this. Really, really ugly. But remember, I said that programming is about transformation. Wouldn't it be nice if I could find a way of expressing this as a transformation? Well, let's do that. I have my word, and now I'm going to use the magic pipe operator in Elixir to say, I want to transform it. How do I want to transform it? I'm going to convert it into a list. Now how am I going to transform it? I'm going to sort it. And now how am I going to transform it? Oh, I'm going to turn it back into a string. All that operator is syntactic sugar for take the thing that's on the left and make it the first parameter of the thing that's on the right. This has nothing to do with functional programming. Any language could do this. But it is a deeply significant thing, because the fact that Elixir has this means that Elixir cares about transforming data. And to me, that is the best, easiest way to read what I'm doing here. I take a word, convert it to a list, sort it, and convert it back to a string. Right? What else could there be? How much harder could that be? Actually, let's do that. I'm going to use slightly, that was the old one. Here you go. So now I've got my word signature function. And if I wanted to, I could actually test that by doing io.puts dictionary.signature of cat. This is where we find out I can't type. All right, so unexpected token end. Oh, always do that. forget the do. There we go. Two things. There's our answer back there, half off the screen, ACT, that's our signature. And above that, you notice it says redefining module dictionary. That's something that takes a bit of getting used to. In the Erlang world, in the Elixir world, it's all about processes. All right, I have a REPL, an interactive shell I can bring up, IEX. When I bring up IEX, I'm actually running something like 25 separate processes in the background, all talking back and forth. The actual interactive command prompt thing is actually 3 cooperating processes. That's the way you write this kind of code. And so as a result, once I start using Elixir on my machine, it's sitting there, it's actually got some background stuff running all the time. One of them is my compiler and my kind of state of the runtime. So dictionary is still lying around. All right, so here we have our dictionary function. Probably the next thing to do is to add some words to it. So let's work how we're going to add some words. So we'll have add words. Okay, now, in a functional programming, we don't keep our state in the module, we keep our state externally. So I'm going to pass in my state, which is a dictionary. But I'm also going to use a default parameter. If I don't actually have a dictionary initially, I'll default to using a new hash dict. So that's my notation for a default parameter. No idea why it's 2 backslashes. It looks kind of crazy to me. And then we'll have a look of words, okay? So there's my function for adding a list, of words. Sorry? Oh, I forgot the do again. Thank you. Pair programming with 50 people, that's wonderful. Okay, so now what I want to do is to take that list of words and convert it into a dictionary. So I'm going to use reduce, because whenever I have a collection that I want to convert down into one thing, then the correct thing to use for that is reduce. So I'm going to say enum.reduce, and what am I going to reduce? The words. My initial state is my dictionary, which is either full or an existing dictionary. And what am I going to do? I am going to add one word to that dictionary. Now, at this point, I could write my function in line, but I'd rather not. I'd rather actually have a separate function that did that. I have a number of syntaxes I could use. I could say, I'll take a function which has a word and a dictionary, and then I'm going to call add one word, word dict, end. Perfectly valid Elixir code. So fn is a way of introducing an anonymous function. It takes 2 parameters, and I'm then going to invoke another function, which I haven't written yet, called add one word. However, anybody spot the duplication in there? Well, yeah. We have like this parameter sequence here that we just basically forward to this guy. So Elixir actually gives me a shortcut way of doing that. I can say just create me an anonymous function that calls add one word, passing the 2 parameters that are passed into that anonymous function onto the add one word function. Yeah? So there is my top level. It's just going to iterate through calling add one word. What does add one word look like? So def add one word, and that takes a word in the dictionary. Do, I remembered. Let's tidy up this code. And now I'm going to call a function of dictionaries. I'm going to say dict.update. I pass it the dict. I pass it the key that I'm updating, which in this case is signature of the word. Now, let's shrink that down a bit. Is that still readable if I shrink it down? Okay. So what am I going to be adding? If the dictionary doesn't already have that word in it, then I'm going to start with an empty list. If it does have that key in it, then I need to append my word to the list. And again, I can use a function for this, right? Yeah, it actually is going to expect a function in this place. Now, I could do the same thing by using the fn and generating an anonymous function. Elixir gives me a glorious shortcut for this. And that is, I can create a function around a list. And in this case, my list has the existing words in it, and that's represented here by &1. and I just use the list constructor to append my new word, to actually prepend my new word to that list. That's pretty cool. Now, I like a programming language that surprises me every now and then. If I'm going to have a long-term affair with a programming language, right, I don't want it to be boring. I don't want it to be dull. I want it to be like, you know, a little buzz every now and then. Ruby does that. Ruby does that all the time. If you've used Ruby, you'll know that it's got all sorts of little hidden corners. I mean, I've been doing Ruby probably as long as anybody in the United States. And I still find new, surprising things in Ruby. Well, while putting this talk together, I actually discovered a new surprising thing in Elixir of the same kind of stuff that I would see in Ruby. And that is, I can use that anonymous function syntax on strings as well. So if I wanted to create a list of, say you know, I have strings with a sequence number in it, I can actually do in num.map 1.100, and the function I'm going to call is the string line hash open brackets ampersand 1. And what that does is going to generate line 1, line 2, line 3, line 4, line 5, up to line 100. I had no idea you could do that. I just tried it one day and it worked. So that's the kind of thing that keeps me coming back to a language, that kind of cool stuff. All right, so now we have add words and add one word. I notice that my signature function here is probably not an external function, so I'm going to make it private by just putting a P at the end there, so that's def P. And also, I kind of like my functions to be on one line if I can. So let's just shrink that back up into one line. And then you'll say, but Dave, that's actually 3 lines. And yeah, because I got that do and end there. Well, one of the cool things about Elixir is that it is very soft. And in fact, def module, def, in fact, almost every control structure in Elixir is not actually Elixir syntax. It's actually a macro. And in fact, do end is not the real syntax. What actually do end does is it actually generates a keyword parameter to my macro def called do. And knowing that, I can actually replace this code with an explicit keyword parameter. And I like doing that. And one of the reasons I like doing that is it actually forces me, to think about writing single-line functions. Because if I follow this rule in general, which is if you can generate all your functions like this, then all your functions will be a single line of code in the body, and just makes it easier for me to read. Okay, so should we see what typos I've made in this piece of code? Ooh, many. Excellent. Okay. So redefining module, undefined function, dictionary.signature. All right, what's wrong with that? Oh, sorry. Where's that? You have to. It's private now, right? Yeah. Oh, thank you. Because I don't want to do, no longer do I want to do that. Instead, what I want to do is to test out my add words. So I'll say add, dictionary.add words. And I'll use a list constructor, which is built into Elixir. So I'll say cat, dog, act, God. Why not? There we go. Okay. So now I've constructed my hash dict here, and you can see the key is DGO, that's the words in order, and then the 2 words that have that key are God and dog, and then act, and the 2 words that have that key. All right. Now, you notice I'm doing testing by running, which is, to my mind, a perfectly good way of testing, but I know that there are wimps out there that insist on actually writing tests. If you do that, you can actually do some quite cool stuff in Elixir. So let me actually show you an example of that. Def module wimpy test do use x unit.case test. I'm going to open that signature function. Assert signature of I'll say cat equals ACT. Okay, so that's a fairly straightforward test, yeah? Testing that the signature works. Now remember I said everything is a separate process. XUnit is my testing framework, is a separate process too. So I'm gonna have to do a start on that just to get it running. And I'm gonna get rid of this line just temporarily. Every single time so far. Every single time so far. What's wrong with dictionary.signature, you're right. Dictionary.signature, and it's still private. Oh, no, it's not private. Okay. There we go. So I ran my tests, and I got a dot, right? Right. Anybody that runs unit tests, right, for them, dots are like the little food pellets that come out in those experiments involving rats, yeah? You keep banging your nose against it to get more dots. Yay. What happens if you actually deliberately make this test fail? It should fail. Maybe because of that. Yeah, there we go. Okay, so there's the errors I get if a test fails. And the cool thing about this is it's all macros. So the macros can get to my source code. And so they can actually say that the code that ran was this. And the left-hand side evaluated to ACT, while the right-hand side was AT, which is kind of useful. And just because it's all macros. Anyway, tests are for wimps, so let's get rid of all that. So the last thing we need in our anagram finder is something that finds us the anagram. So we'll just write something called anagram of, and this is going to have to take a dictionary and a word. And let's assume we can write this on one line. Oh, of course we can. It's just going to be dict.get dict signature of word. Okay, and then we can call that by saying dictionary.addWords that. Actually, let's do it in 2 steps. So on the first step, we'll add those 2. And then on the second step, we'll add those 2. And then we'll say, what are the anagrams? So we'll say io.inspect dictionary.anagram of cat. You know what? If I'm going to keep going, every single one will go wrong, and then I'll be happy, okay? Line 5 has an extra 1 on it. Any decent language would have gone, hey, an extra 1, I could use that. But no, not Elixir. Undefined function dict on where? Line 18. Dict equals dictionary, add words that. Oh, there we go. I'm going to give up. I'm going to give up. Undefined function anagram of. I guess it would help if I put all the parameters in, wouldn't it? Hallelujah. All right. So, as you can see, Elixir code typically works first time after it compiles. All right. So that's all very well. But remember I said the feature is concurrent. So let me just come back to that. You've seen that. So transformation is key, and we showed the transformation a couple of times in terms of that pipe operator. I use that all over the place. But I also want to talk about concurrency. Now, you can't really look at concurrency in Elixir until you look at Erlang. The Erlang virtual machine has grown over the years. It's been tuned, it's been rewritten a number of times. It's not the highest performance VM out there, it's not bad. But what it does do well is processes. All right? When I talk about processes here, I'm not talking about operating system processes. It does its own. And it does them really efficiently. So on my little laptop here, I can spawn up probably a couple of million processes. and have them all talking to each other, depending on what's inside them, but typically, a couple of million would be reasonable. And those processes can be monitored, so if they crash, they can be restarted. I can save their state and reload it. I can upgrade their code, and if the implementation has changed, then I can actually migrate the state as I migrate the code automatically. I can run a global network of these things and monitor them. It's a really impressive achievement. So, in Erlang world, I have basic raw processes, and I have a few primitives for doing that, surprisingly few. I have the ability to spawn a process, I have the ability to monitor a process, I can send messages to it, and it can receive. And it handles exceptions and things, but basically, that's it. On top of that, there is a software layer, a framework called OTP. OTP has like godlike status in the Erlang world, but fundamentally it's just code, right? It's code that gives you a framework in which to write large multi-process concurrent systems. And then, if you've ever used Erlang and you read the documentation on like how to write an OTP server, the first line of the instructions is always copy this 105-line boilerplate into an empty file and then fill in the gaps, right? That's kind of like using, old Microsoft IDEs circa 2000, right? Where the first thing when you create a project is you get 1,000 lines of boilerplate code. It's just crazy. So Elixir uses the power of macros and modern programming to get rid of all that. So Elixir gives you libraries that make OTP kind of like feel a lot more modern. And I'm going to show you just one aspect of that. I'm going to show you the Elixir agents. Because when you have functional programming, it's really hard to keep state lying around. My dictionary is state, right? I'm going to load things up into it and maintain that. You notice in the previous code, I passed that dictionary around all the time because the module itself cannot hold state. Well, the other way of holding state is to keep it in a process. And that's what we're going to do. And in fact, I'm going to keep my state in a fully managed OTP process that can participate in supervision trees, code reloading, blah, 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 blah. But I'm not going to write any OTP code. I'm going to use a brand new abstraction. In fact, this one isn't currently in the Elixir 0.13.0. It will be in the next release, which is coming out this weekend. So I'm going to use something called agents. And an agent is simply a way of maintaining state. It's a background process that runs. You start it by saying start link. You pass in a function that's used to generate the initial state. So that function runs not in your process, but in its process. And then you can give it some options. And the one I'll be using is name. I'm going to give my process a name. And then there are two basic operations on a process. I can do a get, which goes and runs a function in that remote process and returns the result of executing that function. Or I can do update, which does the same thing. It runs a function in the remote process, but actually sets the state in that process to the result of that function. And then it just returns OK. It doesn't actually return the new state. So those are agents. So let's actually code up. Oops, sorry. So let's code up our dictionary to use agents instead. And to do that, we could just basically integrate those two pieces, the code, and make agents part of our existing code. But that's kind of ugly. So instead, what I'd like to do is to take my existing code here. Hey, there's another one. Look at that. Take my existing code here. And if you look what I've got here, here I have basically API plus implementation in those, what is it, 3 functions plus 1 helper function. Let's make that private again. Yep. So I have, here's my API and my implementation. So what I'd like to do is to split that into 2. And to do that, I'm going to use a kind of like ugly notation. I just put do in front of all of my implementation things, and I'm going to make all the helper methods private. Yeah? So these are implementations of my API. Now let's write the API. And the simplest API is just to say def anagram of, but I really just want to pass in a word, right? So here's my first, oops, thank you, autocomplete. And my second API is going to be something like def add words, and a list of words. Okay. So there's my API. Here's my implementation. I need to hook the two together. Now, if I was just doing this inline, then I'd have to pass an extra parameter, a dict parameter, into both my API calls up here, and they're basically just reflecting straight down to the implementation. But I don't want to do it inline. What I want to do is I want to run all this code in a separate process, and then get to it through my API. So to do that, I'm going to use agents. So first thing to do anagram of is I need to run that call to anagram of in a separate agent process. And I'm going to assume my agent's got a name. I'm just going to call it @name for now. And what I'm going to run, well, I want to run a function in that remote process. And that function is do anagram of. And again, I could spell it out using fn and create an anonymous function, or I could just use my little shortcut here and say ampersand do, oh, wrong one, anagram of. And I'm going to call the version of do anagram of that has, actually, am I going to do that? Yeah. Okay. So here I am calling my do anagram. I'm creating a function that when it is invoked will call do anagram of. The agent is automatically going to supply its state as the first parameter, and then the word is going to come in as the second parameter. Now the state is going to be the dictionary, so by the time it gets to do anagram of, it will have the dictionary in the first parameter, the word, and it will just return it. Now, I'm sorry? It's running a separate process, not a separate thread. Threads, we don't talk about threads. Threads are evil and dirty and disgusting. Please go wash your mouth out. No, we're using processes. So the entire idea of the Erlang process model is that you run separate processes that you can only talk to by sending messages. So there's no shared state, and the data inside them is immutable. So you actually get rid of 99% of concurrency issues just go away because of that one abstraction. Yay. Okay. So this, yeah, but it's going to run in a separate something. Yeah. And in this case, it's running synchronously. I could also run it asynchronously if I wanted to, but I want to do it synchronously for now. Now, to add words, I'm going to call agent.update. And again, I'm going to pass in the name of the agent that I want to call. And then what I want to do, well, I want to call my add words method. So again, I want to say, sorry, do add words, isn't it? And the first parameter is going to be the agent's state, so that's &1, and then I'm just passing in the words. So there's my API to my agents, except for one thing. I haven't actually created my agent yet. Right? I don't actually have an agent process running. So to do that, I'm going to say, and this is just a pure convention, right? The function's name is spawnLink, again. And the reason we call it spawnLink is that we're spawning a separate process, and we're linking to it. And linking to it basically is to do with error handling. What this means is if I die, it will automatically kill my separate process. And if it dies, it's actually currently going to kill me as well. And to do that, I'm just going to say agent.spawnLink. Do you remember on that slide, the spawnLink takes a function that generates the initial state. So in this case, I want to create a new hashdict. And I could, again, use fn that returned hashdict.new. Or I could just say, hey, call the hashdict.new method. And I want you to call the one that has no parameters. That's just a notational convention that says, this is the name of the function. And I'm going to pass in the name of that. Now, what is that name? Well, I've just used basically a module annotation here. I can just type @name at the module level and then give it some value. So you can call your agents anything you want. A convention that I don't like very much is to actually name them after the module. So in this case, the module is called dictionary. So if I say underscore underscore module, that gives the name dictionary to our agent as well. The reason I don't like that is it can make stack traces kind of hard to follow because a dictionary means two things. So if you don't like that, you could call it something like dictionary agent or something like that. Totally up to you. Okay, so syntax error spotting brigade. Before I hit Command B and embarrass myself, do you see anything? Come on, this way we share the blame, right? It's not all my fault. Okay, this isn't going to work. I'm going to comment this out for now. Good Lord, it actually compiled. All right, so let's put some code back in here. So the first thing I have to do is to start it. So I'm going to say, oops, dictionary.start link. Did I say spawn link? I did, didn't I? I should have said start. Sorry. That's what happens when you talk and type at the same time. I said spawn and then type spawn. Okay, so dictionary.start link. So now I don't need to keep this separate variable lying around. I can just say dictionary.addwords, dictionary.addwords, and then say dictionary.anagram of. And I guess it would help if I said io.inspect. Good Lord. All right. So here we have our, I deserve that because that's the, that's the first one that's actually worked. Sorry about that. So what I have here is I had my free running agent running as a separate process, and I wrote an API to it in my module, and the API just delegated all the work out into that process. So first thing, if I have a whole bunch of clients that want to use my anagram dictionary, they can. I got 4 cores on this machine, so in theory I'll have the agent running in one, and I can have 3 other clients to that running concurrently on the other threads, which is pretty cool. But I can do slightly more than that as well. What do they call dictionary? This is IEX. IEX is interactive Elixir. And it does all the things you'd expect to be able to do. Yeah, so I can just basically type in Elixir code, and it runs. All right. This is the thing where I said I'm actually running 25 processes that are all talking back and forth, which is kind of scary, but it's true. All right, so what I'm going to do is back over in my code, I'm going to make a slight change. Here, I just said the name was dictionary agent. This, by default, is a local name, so it's local to the particular thing I'm running. I can make that a global name by saying global, I shouldn't have raised dictionary agent, sorry about that, dictionary agent, okay? So now, this is going to register this particular agent globally. Not globally as in the entire universe, globally in all of the various Erlang virtual machines that I've chosen to link together into my application. And I can do that manually, if I can find the screen, here. So I can link together by basically giving my nodes a name. So I can say IBS minus S name, that means a short name, and let's call this node 1 at, and my computer name is actually called faster air, because I have no imagination. It's faster than my previous air. And what was that module called? Was it dictionary.ex? Yeah. Oh, sorry. Before I run this, I don't want to run my code automatically, so I'm going to get rid of this code at the bottom. So it's just a pure module, okay? So now I'm going to start up my first node, do the same thing down here, minus S name. This one I'm going to call 2. Now, you don't normally do this manually like this. Normally, your applications are all configured in a release, but I'm just going to show it to you. Now I'm going to link these 2 nodes together into a very small network. Now, I could do this on 2 separate machines. I mean, in theory, if I was on the Wi-Fi, you could do the same thing and link into my nodes here. So I'm just going to say node.connect to. This is a 2, so I'm going to connect to 1 at faster air. OK, so now my 2 nodes are connected together. Up in this node, I'll say dictionary dot, Start link. So my dictionary agent is actually now going to be running up in that virtual machine, up the top there. All right? Down in my other virtual machine that's linked to it, I can say dictionary.addWords cat and dog. Up in this virtual machine, dictionary.addWords, oh, I don't know, God and act. Okay? And then, and you can imagine like a whole bunch of processes all out there reading dictionaries and adding words in, all in concurrently. So now I can say dictionary.anagram of cat, and I get both of them. So both nodes have been added in, or both nodes as input have been added in. Down here, dictionary.anagram of. All right. So I have these two nodes linked together. Now you may say, yeah, but okay, Dave, I could do that with agents in any other programming language you want, right? That's not a big deal. Sure. I'm not saying that this is better than anything else. I am saying, however, that these particular agents are now participating in all of the goodness that I get with the Erlang virtual machine. So I could run 1 million of them on a laptop, although actually with a dictionary that would probably get a bit big. I could run them on machines around the world. They are currently being supervised, although they're not going to be restarted automatically, but I could very simply arrange them to be restarted and their state reset. If I didn't like the code, I can actually change the code on the fly, all because I'm running in that virtual machine. So that's really, really powerful. But the other thing I wanted to show you, modulo my bad typing, is how we took that code and transformed it in the same way we transform data. And because our code was decoupled from the underlying representation, that was really easy. All right? I didn't have to like move things around and add new classes and stuff. The code is decoupled from the data. And to me, that's the second really big benefit of doing this style of functional programming. So that's just an example of code. I'm not going to show you tasks because it's just another side of the same coin. So why Elixir? Okay, the answer is it doesn't have to be Elixir. I don't care what language you use. I happen to like Elixir. I happen to like Ruby, but you could like other things. I don't really mind. But whatever it is, if you're not currently doing functional programming, start. All right? There is a word for people 5 years from now who are not doing functional programming. And that word is maintenance programmer. Right? You've got to start. You've got to start learning concurrent programming. And I don't mean threads, with all due respect, right? But true, genuine, reliable concurrent programming. And distributed programming, the two are different. Because that's going to be the world. The world 5, 10 years from now is going to be, this room is going to be full, 10,000 processors, all just floating in the air or attached to the light bulbs, whatever it might be. And we're going to be programming those things. So we need to learn how to do it. And if you're going to do that, then why not have fun at the same time? Right? Programming has to be fun. Programming is such hard work that if you're grumpy doing it, you're going to turn out crap code. You have to be enjoying yourself when you're programming. And so make it fun. Find a language that makes it fun. Elixir makes it fun for you. Scala might make it fun for somebody else, or Clojure, or whatever else it might be. But find something, learn it, and make it fun. But the main reason, obviously, to learn Elixir is that I have stickers. So if you guys want stickers, come and see me. All right. Oh, that's just blatant advertising. That's it. I just wanted to show you that the idea of transformation is key to programming, and Elixir makes that easy. So thank you very much.